Beautiful. Sweet. Welcome in, everyone. We are on week 7. Hopefully, you guys saw the message I was able to put in on NetAcad, where I kind of talk about the benchmark. We just hit week 6, so we're kind of halfway mark now. It's kind of like it's week 7 out of week 12, so another 5 more weeks or 6, including this one, I suppose. So I hope you guys take a look at that message I put on NetAcad. It's distracting. Look at my face when I talk, but we'll be pretty much just the rest of the quarter. We'll just for this class, we'll be going over module 4. After this week is pretty much the last week of module 3. I'm going to be assigning another module 3 assignment. As you can see, oh, this is actually your old if statement one, which I want you guys to finish. I think I only have one submission at the current moment, so I would love. I know I gave you guys this a little bit late, but just want to give you this, do this one. And then I'm going to be also assigning a loops assignment. They shouldn't be too hard considering, at this point of like module 3, we're finishing it up. This should be more of a review session. And if you have any questions, feel free to always message me, put me on NetAcad, email. I'm very more than happy to help. If you guys want to do office hours, I can schedule office hours. But that's pretty much it for that. I want you guys, just as a reminder, that module 3, module 4 is pretty much the hardest parts of this class. So the assignments will be getting ramped up. I'm going to probably put in for the next 5 weeks, you're probably going to have another 3 assignments, 3 more or 4 more assignments. So it's going to be assignment each week. So just as a reminder, keep that in mind. It's not like before where it was much slower paced. We're getting much, into the more of the thick of it now. Luckily, we do have 12 weeks, so it shouldn't be as fast paced as it was before. But I want you guys to be doing that. Module 3, I noticed only 2 people have completed module 3 test, I believe, which is fine. We're going to go through module 3 test at the end of class today. I'll try and do it with you guys, just kind of did like with module 2. And a reminder, if you haven't done module 2 test, go back and do that. I have a video of that, of me doing it. I don't remember which week, but I do actually go over some of the answers in it. Same way we're going to do module 3, I'm going to go work with you guys a little bit on it. But as a reminder, again, to take the exam at the end of the semester, the PCEP exam, the entry certification exam for Python, I require that you guys finish the assignments and finish the module test, which shouldn't be, I think most of you guys finished module 1 and 2. So module 3 and 4, we're about to finish module 3 test. So do the module 3 test after this class, and then do the assignments that I assign you guys. And the assignments aren't meant to be too hard. It was just meant to be, and I'm pretty sure you guys figured out with the last assignment. It was about like 10 lines of code. This one might be a little bit more than 10 lines of code, but it's going to be maybe 20 lines of code, which isn't much because you're just going to be putting if statements, right? Your program prompts the user to the cost of renting one room, the number of room books, just exactly like how you guys did before. You say input. The cost would probably be an int. Maybe it's a float. You want to see what the cost of renting one room is. The number of rooms booked, that would definitely be an integer because you say int input. The number of days of the room are booked, that could be an integer as well. Sales tax, that would probably not be an integer, that'd probably be a float because sales tax would be a decimal most likely. So those are your inputs that you would probably take. And then your outputs, which you'd be printing out the cost of renting a room. And this is your if statements, which is going to be like, if the number of rooms booked is more than 20, which was right here, number of rooms booked, the discount is 30%. More than 10, the discount is 20%. Otherwise, the discount is 10%. Those are your if, else if, elif, and then else statements. So hopefully you guys get a good remembering, or I guess jog your memory of that. And then make sure to test your code. And if you test it with this sample code we put in here for you, all you have to do, you should get these outputs when you run them. And then we also have an invalid, how many rooms are booked, 0. And we're going to say if you book 0 rooms, you don't pay anything because you're not booking anything. So this is a good program for testing and stuff like that. If anyone has any questions, feel free to put it in the chat and I'll answer it. But that's pretty much all we have for this assignment. I'm going to also assign a loops assignment probably after today's class. So make sure to finish this and then try to finish the loops assignment. We're going to hurry this stuff up a little bit more. And then also what I want to say is because of myself, I might have a scheduling conflict. The class started a little bit later than what it was originally supposed to start on. because I'm a master's student as well at UCSD, my class next quarter is interfering with this 4 to 5 hour. Would you guys want it to be? Would you guys want me to reschedule to 3 to 4 or 5 to 6? Feel free to put this in the chat. And of course, these will all be recorded if you guys want to rewatch it. And if neither of those options are okay, I have another instructor who's my dad, who is actually a professor, a full-blown professor of computer science, who taught this class in the past, would be able to teach this at 4 to 5 on Mondays. So my question would be, what would you guys prefer? Keeping this class at Monday 4 to 5, 3 to 4, or 5 to 6? Mario said 3 to 4. And this would be great to hear from everyone, because this is, if you want to come have this live time work with me, Monday 4 to 5. Okay, so that would be, so Alessandra would say Monday 4 to 5. And again, if it's Monday 4 to 5, if you guys are, and that's perfectly fine if it's 4 to 5. Oh, thank you, Mario. If you're 4 to 5, it'll probably switch instructors. I'll still be doing all the online stuff, but if it's the 3 to 4 or 5 to 6, I would be still here working with you guys. But I'll still be always with you guys. If you have any questions, I'm going to be the main instructor for online. So I will be doing all those things for you guys. So Monday, so we have 3 to 4 from Brandon Mario. So from the rest, you know, I know I should probably go and ask the rest online as well at Netacad, which I will. But at the current moment, we have 2 people saying 3 to 4, and 1 Alessandra. If we have more people wanting to pick whichever one, that'd be great to hear from Sebastian or the rest. Alessandra. Not Alessandra, Dogfin, 5 to 6. Okay. This is kind of tough. We're getting some split answers here. I'll go and put this in the Netacad chat as well, but I'm going to keep hold of this as well, so I'll know that there's what number it is. But just as a reminder, whatever it may be, there will be a recording on YouTube like always. So don't worry too much about your class being about not like seeing anything or not being in live time with me. It'll be recorded. But just for people who want to be here in person, or not in person, but live time working with us. So for the rest of you guys, feel free to put in the chat, Sebastian, Moses, and I think that was pretty much it. I think everyone else responded. So Sebastian and Moses, yeah, if you guys want to put in the chat when you guys are working, what works better for you, Monday 3 to 4? Oh, Monday 3 to 4. Okay, sweet. So anyway, and in the chat, that's great that you guys are all putting your answers there. Looks like 3 to 4 is a strong. Oh, 3 to 4 seems to be strong then. So we'll probably, I might do 3 to 4. I'll put it on the chat as well in Netacad and see if everyone else responds and see what that comes out to. But we'll stick with, we might be doing 3 to 4 next week. So I'll send out an email if it does go 3 to 4. And then I'll also be posting recordings as usual. All right, sweet. I'll get into the work now. So guys, reminder, do this. Do the modules. I want you guys to do I want you guys to get your guys entry your certification exam, because if you do all the stuff, you get to take the exam for free and hopefully pass the exam, and then you guys get to be certified. And I just want to give a quick reminder that being certified in computer science, Python isn't the goal for me. It might be the goal for Napa, but for me, my goal is to give you guys a good foundation of computer science so that if you guys want to do this in the future, you guys can and hopefully will, because I do actually enjoy doing this and I enjoy working with all of you guys. But will there be spring break? I don't believe there will be spring break. I'm on spring break currently, actually, but I don't think you guys have a spring break, considering it's just 1 class a week. So no spring break, but it's a good question. I actually kind of did wonder about that too. So no spring break. And if you guys want to take a break, just take a break off the showing up to class and then watch the YouTube video later. All right, sweet. And then I will, let me stop my share. Let me go back and I want to share, what do I want to share right now? I want to share I have a list because I don't have my usual stuff up today. We're gonna go finish module 3. So we're gonna go to 3.6.1.8 and I am going to share that part with you guys. Right here, perfect. So we're gonna go to this. This is the part we didn't get to finish. And this is the cool thing with our class, is that usually in the past it would be much more faster. It would be 10 weeks. So most of the time they don't get to go through this as much. But when we look at 3.6.1.8, we kind of already talked about operations. And then also I just want to give a quick little thing on down a list on sorting. Sorting is really good to know. Make sure to look at of course, look at all the modules you have. But the bubble sort algorithm is a really common like sorting algorithms. There's a whole load more like insertion sort. Insertion sorts. I said whole loads more than I can remember. Quick sort. Quick sort is kind of funny. Some of them have names that say they're fast, but they're not actually that fast. I think quick sort's one of them. Merge sort is probably one of the best, but those are different sorts for different complexities. But it's good to know sorting algorithms is one of the common keys of computer science, is knowing sorting algorithms. So make sure to take a look at it. It's just pretty much like if you give me a list of 10, 7, 6, 5, 4, 3, 2, I'm going to return a list back to you of 2, 3, 4, 5, 6, 7, 8, 9, 10, right? It seems easy, but it has a lot of nuances because, and sometimes in bubble sort, it may take more time with how many times you go through the code. For a list that short, it'll take you 1 second. But when you start going into the big list, like if you keep going into computer science, you'll work with like million numbers, billions of numbers, some trillions of numbers actually is a possibility. When I worked at the government for Department of Energy, they would work with petabytes of data, and petabytes are, I don't know, it's humongous is pretty much a way of saying it. So there are times where you will go through like so much data. And so it's really good that sorting algorithms you have are efficient and good. Bubble sort would probably be really bad to use on something like petabyte size, but it's a good start. But if we go into list processing, we talked a little bit about it. Memory location, where the list is stored, the name of the ordinary, the name of its contents, list 2 equals list 1. We could talk about that last one. We talked about lists, deleting. We didn't talk about slices, where slices is literally just a way of creating a new array or new list, where you can kind of signify which list it is. So in here, I'm just going to do my own example. So right now we have this, copy paste. And again, the sandbox is a really great tool for coding. If you guys want to, I love actually coding in this. Bite size, was that a pun? Actually, it wasn't a pun, but it's a good pun actually to be made out of that. It is a good thing of saying bite size, yeah. I didn't think about that. So this one is a slice, right? Where we have my list, print new list, 10A642. It kept the exact same thing. But if I set it where I made it, let's do 2, nothing at the end of it, it prints 642. So 0, 1, and it starts from position 2 and takes everything to the end of it. Now, if I do this, where I put 2 after the colon, if you can probably take a guess, it's everything before the second element. So 0, 1, and then it doesn't take anything past it. And remember, usually on the right side, it means we don't take it, right? So here, if it's on the left side, we're going to take it. So we count the second element, 0, 1, 2, 6. But if it's on the right side, we only do 0 and 1, because just how you do your for loops. You don't actually count the last number usually. It's a good way of remembering. So that's a slice. Slices are really good for things like this, where in this case, we have my list, and they just do delete my list of colon, and all it does is it deletes everything. So if you do a colon, nothing before, nothing after, it'll take everything. And then if you put nothing after if like how I said before, if we did 2, it takes everything after it counts. So it goes it'll delete 6, 4, and 2. But if you go from before, if you put a 2 after it, we put a 2 right here, it'll take everything before the second element, right? So before, after, left colon, right colon, hopefully kind of starts clicking in. If it doesn't click in, just do some more examples. That's the best way to put it. It'll click, but I hope that was a good, hopefully shorthanded way of showing you how a slice would work. But slices are really important. And then there was another thing where we haven't talked about this, but LM in my list, LM not in my list. This one's pretty nice because all it does is just tells you, is it in the list? Yes, not in my list. It's pretty good by English, I would say. It's very easily summed up. Is 5 in the list of 0, 3, 12, 8, 2? No, false. Is 5 in my list of, is 5 not in my list? There is no 5 in that list, so that's true. Is 12 in the list? Yes, right here. So true. So it's a pretty simple way of doing it. We'll go a little bit more into depth in it when I think it's this one I want to go over. Was it this one? It wasn't this one. It was this one. Sweet. So here we have this one, and I encourage you guys to do the labs of these Neticats. These are really good like tools to help you. And they even put estimated time difficulty easy. I'll work with you guys on this one because I think this one is a little bit of a fun one. So here we want to create a unique list, right? So we have the original list right here. Now I'm going to make a unique list, and let's say we want, does anyone know how to initialize? This is called initializing. If I want to make an empty list, how would I do that? What would I put right here? Or I guess right there. What do I put in here to make an empty list? Because in our unique list, we're going to create it based off of our elements in my list. Anyone have an idea of what we could do to make it unique, or not unique, or what we could do to create an empty list? We did it last week as well, if anyone can remember. It's similar to this. I'll call on someone. Dogfin, can you tell me which one this would be? Well, what would how would I,
with just a space in the middle?
like this?
Yeah.
Exactly, right? It's exactly how we would create a regular list, but we put nothing in it. So an empty list. So in here, we want to add all the elements using this, right? Or we want to add all the elements that are unique in here. So my first idea would maybe, let's say we can create a counter of all the times we hit it, right? We had that, there was another example in here of how many times we hit it. So let's say for number in my list. And if you have a better way, I would love to hear it. My way might be wrong. So number in my list. So what we're doing is in this loop right here, just as a quick reminder or jog your memory, is that all I'm doing here is I'm going to go through each number, 1, 2, 4, 4. It's going to go through all the numbers in the list, meaning it's going to start 0, 1, 2, 3, 4, all the way till we hit the length of the list minus 1. So when we're in here, we have all the numbers. So we're going to say, let's make a hit counter. We'll say 0. And we'll say if, let's say if number in my list, right? If that number's in my list, we can say hit plus equal 1. So we made a counter, it hit. Then we can say something like unique list dot append. And if you remember, append will add it to the end of the list. And here we have an empty list, so it'll just keep adding numbers to the list. It'll go 1, 2, 3, 4, kind of like how you would think it would work. And we'll say hit, or not hit, we'll say number, right? We want to append that number. I think that would work, right? Or let's make it, well, we want to say if hit is greater than 1, this makes sense to me, right? If hit is greater than 1, unique list dot append number. Or we don't want to say is greater. We want to say if it's less than 1 or less than 2. Do that, right? Because if we hit any more hit times, we don't want to append it anymore, right? That sounds about right. Or we could say equal 1. This would mean that only if we hit it once, then we know it's good. Does anyone have a problem with this? You think this would work? Anyone in the chat can just say true, false to me. Do you think it'll work? Won't work?
Isn't it going to add the same number to the list a bunch of times?
And you are exactly right. I haven't printed it out. I was hoping to give a good interest, but great job. You figured it out, right? Boom, it does the exact same thing. We didn't change anything about it because it's always going to hit it once, right? If that number's in the list, it's going to append it once. What we could do, maybe let's get rid of this hit thing. I don't think this clearly didn't work out for us. What's another way we can do this? How can we do this to make this get all the unique numbers in here? If number is in my list, Print unique list. Anyone have any ideas? We'll work on this together. I made an answer for this, but I don't even remember it myself. So this is for number in my list. If number is in my list, we'll print that unique list. So we don't want to do that, because if we're in here, we'll say if the number is in my list. Yeah, that's true. Maybe what we could do is if number is in my unique list, append it. Let's see if this works. Does everyone have any qualms with this? And we get nothing now. That's not what we wanted. Anyone have any solution here? For the number in my list, 1, 2, 4, 4, 1, 4, 2, 6, 2, 9, right? We go through all that. If the number is in the unique list, we want to append it. But what happens is when we get into that number isn't in the unique list because the list is empty, right? We also have this cool thing called the not in operator, right? So I can say not in unique list. So all the numbers that don't show up in here, put it in here. And what do we get now? I hate, this is the one thing about Sandbox I do not like. You have to refresh it. I wish it just, there we go, we got it. Because all we had to do is in this loop, I'll walk it through you guys in English terms. That's the best way I like to code, is I like to think of it in English and then code it. So in here, and that's always the best thing to do, is write out your code first and then actually code it. That's always the best practice. Whether or not everyone does it, the answer, not everyone does that, but when you get to complexer and more complex ideas, it becomes a requirement that you have to write it down first. Like when I do my assignments in college, I write it down first, because if I don't, I'm gonna get so lost. But that's just a tip for coding. But here, for number in my list, we're gonna go through all the numbers in the list. If the number is not in unique list, so if that number is not in here, we'll add it to that list, right? And if it's, so if we get 1, 1's not in this list, add it. 2's not in this list, add it. 4 is not in this list, add it. 4 is in that list now, so we don't add it because it's in that unique list. 1 is not in that list, 4 is in that list, 2's in that list, 6 isn't, we add it. 2's in the list, 9 is not in the list, add it. So hopefully that English, I guess, summary of it hopefully was pretty decent. But that was just one of the things about it. And this is one of the fun parts about coding. And the cool thing is your lab, they give you a bunch of these lab exercises. I actually enjoy doing this. It's actually really fun. It's like a puzzle game. So if you have any free time, look up coding exercises. They're pretty fun to do. Or maybe I am. I sound so nerdy by saying I love like doing this. And I remember when I was in college, I'd hear people talk about, oh, I love coding. I'd be like, this guy, I'm like, who actually loves it? They're joking. But when I do this stuff, I'm like, this is actually kind of fun. It's like doing like a puzzle. So maybe I sound a little bit not like I'm not trying to be like, oh, it's actually fun. Like, to me, it is actually fun. It might sound a little strange. So in here, what we talked about, this is 3.7.1. So this is going one chapter, the next chapter, and the last chapter, module 3. This is the part we didn't get to talk about, which is multidimensional arrays, which is just a multidimensional list. So what we had before was when we had a list, right? We would say list equals 0, 1, 2, 3. I don't know. I'm putting a whole bunch of numbers in, right? When we did that, and if I print list, we'll have, this would be called one dimensional because it's just one row, right? It's one straight line. It's a linear. But what we could do is there are utilizations or things you do need to have multi-dimensional lists. And a good way of thinking about that, and this is a really good way, is, let me see, where do they do it? Right here, perfect, is in something like a chess game, right? And this is something that we did actually when I was teaching a course at UCSD, which was we created a what is the game called? Connect Four game. A Connect Four game, you know how it is. It's like a whole box, right? And whoever puts the token down. And if you get 4 in a row in any direction, you're a winner, right? So that was a really fun thing to code. And if you guys want to try that, feel free to. I can give you guys I can go and try and find the assignment that we created for that. But that was a really fun assignment, which is you just create a checkerboard of things and then you find out who's the winner, and you can play with a friend. You could put X, Y, and this is how you do game development too. If any of you guys ever get interested in that, well, this isn't how you do game development, but if you wanted to create a fun board game, this would be exactly perfect for that. And so here we have a checkerboard, a chessboard. A chessboard is a perfect way of describing, let's try and code this. So in this case, they have board 0, 0 rook, board 0, 7 rook, here, 7, 0 rook, 7, 7 rook, right? We're creating a chessboard. And we could do other things as well. Like if we wanted to say if we wanted to say board 1, let's do 0, 1 actually. I think this is a knight. I believe that's the knight. And that's this position right here, right? That I have my cursor over 0, 1. So it's a knight, right? And I hope that's a knight. Hopefully it's not a bishop. I'm pretty sure that's the knight. So we have there, right, is we have 0, 1, knight. So we have all these positions already detailed for us. This is a really great board to look at. So if you ever get confused, I would say come back to this. But can anyone tell me what, and I hope someone could tell me, can someone tell me what these numbers mean, 0, 7? We know it's their position, right? Because we talked about that in the past, when we were doing the one-dimensional list, where it was position 2 just meant the third, which meant the third element, right? Because we start from 0, 1, 2. So position 0 would be the first element. Position 1 would be the second element. Can anyone tell me what this would mean? Board 0. So we're saying this element right here, 0, 0, is the rook. Can anyone explain to me how we got that 0, 0, 0, 1, 0, 2, 1, 2, 2, 3? Does anyone know any way of how this makes sense?
It's just like a coordinate plane.
It's a coordinate plane, exactly. And also Brandon put in a great thing as well. This is row, column. And that's exactly the best way to think about multi-dimensional array is, I would say it sounds really, let me say, it sounds horrible, right? Multi-dimensional array. When I first heard that, I said, oh boy. But in this way, when you think of it, it's just a row column table. It's really easy for a 2-dimensional array, which is in row 0, column 0, like in the way Brandon put it, and Dog can put it in the coordinate plane, is that this one would be a rook. And here, if we wanted to do this one, 1, 0, this is going to mean row in human terms is a good way. English terms would be, let's do it here. If we want to do the second row, it would be board position 1. And let's say we want to do the first column, it would be 0. If we want to do the second column, it'd be 1, just like how we did it before, because we start from 0, would equal pawn, because all pawns are on the second row. In this case, we would also have it in position 6, because it would be the bottom as well, because the chessboard goes in 2 different directions. So pawn 1 would equal pawn. And something cool to do about this, what I'm going to do before we print the board, is I'm going to comment this out. This is a good way of, this is kind of a little bit confusing at first. So in here, they make a loop that says for I in range 8, row is equal to empty for I in range 8. This is a weird way of doing it, but this works. It's like putting in, it means you're putting empty, you're making an empty row 8 times, right? So he made when they created this, they created an empty. So empty would be 1 row, but they're doing it for in range 8 times. So they're doing 8 rows empty in range of 8, right? So for I in range 8, this is going to go through your rows. It will go through your rows, and then this one would go through your columns. It's a row column, just like how we kind of talked about earlier. And so a good way of printing something out like this one they don't really talk about, but I think it's really good to have. So for I in range of len of your board, colon, as usual, we'll say print. You don't have to truly understand what we're doing here, but it would be good if you want to. So this is going to be print board of I. So it's going to print each row. That's the whole point of what I'm doing. I'm going through the length of the board. The length of the board is going to be 8 because there's 8 rows. And I'm going to print that row 8 times. That's what this is doing. So when I do this and I run it, we're going to have, oh, it still has something that I messed up. Don't look at that trace back. But what we have here is this. We have all that. Is we get to have that, and we get to, that's just an empty chessboard that we made. And I figured out that they did this where they created a constant where they said knight in capitals. Whenever it's all caps, they call this constants. Pawn equals pawn. That's just so we don't have any errors. So now what I could do for here is this kind of gives us a chessboard. If I do print board, this is what it's going to look like. I should clear it because it's going to be really gross looking. Oh, I really do not like this. So let's put a comment here, clear this out because it's gonna. Okay, sweet. Forward 0, 0 equals rook. What's wrong with my rook? Line 14. Oh, it's probably because they don't like this whole loop I created. Yeah, okay, they didn't like the loop. So here it puts everything. It does its 8 things, right? Because it has the 8 columns here. This revolves to 8 columns, and it does it 8 times for the 8 rows that you have. I don't like that. It looks kind of ugly, right? Chessboards don't look like that. So all I'm going to do here is I'm going to take this. Instead of printing board, I'm just going to do that, and I'm going to print board of I. Ow, I just hit my funny bone. And if I bring this up a little bit, hopefully you can get a better view of it. So here, this is it. This is the stuff up here is the old code that we had. This is what it looks like after we run it, right? So now our board looks a little bit prettier. It doesn't have the best spacings because we put rook in here, but rook, knight, rook, pawn, pawn, rook, rook. If we wanted to, we can go by and populate each line. So if you wanted to create a game of chess, this is how you would do it. You can create it in code just looking like this. Of course, if you wanted to make it look prettier like this, you would probably have to use like other tools, but we can make our own game brass tacks, and then another tool will just take it and make it look prettier. So that's pretty cool. So I think that's our multi-dimensional arrays. 4:30. Wow, man, time flies by when you're having fun. Am I right? So what I want to talk about next is just that you can do 3-dimensional arrays. You can do 4-dimensional. You can do as many dimensions of arrays. Although it gets a little bit more complicated. I'll be honest. It gets more complicated. This one you can do a cube, right? They do a cube dimensional array. In my time as coding, I think I maybe use a 3-dimensional array maybe once or twice in my life. So it's not very common or useful. 2-dimensional array is very useful because you usually work with a lot of tables. But if you are, and matrices is the most important thing for 2-dimensional list. But when you're working with something like cubes, if you wanted to, 3-dimensional array, if you were trying to do more geometry work, then I suppose you can keep going in dimensions. I wasn't good at geometry, so I never liked to go further than that. And I don't think anyone asked me to go further than 2 or 3 dimensions. Usually 2 dimensions is the most you do. And then we pretty much finished this module 3. So woohoo! As a reminder, now that you finished module 3, when you get to the stage, you should say, okay, I should go and finish the assignments that Kayvon assigned, which would be ifs and loops, which I'll assign later today. And here we'll talk about this is a quick summary. You talked about Boolean values of if and if else. You use while and for loops, break and continues. Logical and bitwise operations are ands, ors, XORs, those little things that I kind of went over. Concept of list and processing, for loop and slicing. We went over slicing a little bit today. And then multi-dimensional arrays, which we went over today with our chess game. So now with 4:36, let me go see if I had anything else planned out here. 3.6, I think I pretty much went over all the code that I wanted to. So what I'll do right now is, because we have about 24 minutes left. If any of you guys have any questions, feel free to ask any question, but I will go and work on the module 3 test with you guys. So this is kind of me saying we're going to work on it together, but if you do come back to this later on, I hope you guys take the test by yourselves as well, test yourselves. It'll be the same question. They don't really refresh them. But we're just gonna go and work on this together, and hopefully that is good. Hopefully it works out. Actually, before we do that, I want to do one more thing. I'm going to go and look up our loops homework that I'm going to assign you guys, and then we can go into it. I know I feel like I don't want to. I was hoping to take a little bit more time, but it seems like we actually kind of breezed through that a little bit faster than my brain thought. If I go to here, assignments, homework 4. All right, and I'm going to share it, and we'll do this one right here. Okay, perfect. So now this is going to be the homework I'm going to assign to you guys probably today. It has old dates on it from the last teachings of this. So it has the 3.2. This is based off of those chapters. So this is made to work with you guys. So you're going to write a Prothon program. I can't speak anymore. Write a Python program to process grades in a typical college course. Ask for the number of users of assignments given in a course. Make sure the user enters 1 or more assignments. That's kind of, make sure the user entered, this is kind of called error checking, right? Validation checking, which would just be a simple if statement, right? So all I would do here is say if the user enters 1 or more assignments, if assignment input is greater than 1, do the thing, must use a loop to validate the input. Oh, we ask you to use a loop here to validate the input. I take that back, but you'll figure that out when you're doing it. When you create your loop, you can put an if statement in there. Or you can just have your loop go up to a certain number. And if that number doesn't work, then you say, hey, you didn't do anything right. Once you have a valid number of assignments, once you finish using your loop of inputs, right? So I'll give you a hint for this first bullet point is ask the user in a for loop, ask the input. So you'll keep repeating it over and over again. And then once this person is done, you can break out of that loop. And if there's not 1 or more assignments, you say bad. If there is 1 or more assignments, you just continue working on the rest of the code, which would be ask the user on each assignment and calculate the average assignment score. You can do this in the first step, valid between 0 and 100. Calculate the final letter grade based on the following table: A, B, C, D, F. Display the message student report, display the letter grade. Again, these are very small coding assignments. It may seem a little bit complicated when I said it, but again, you're expecting maybe 20 to 30 lines of code. I think that's even, I think I might be over exaggerating it. So when you do this code, it shouldn't be too much work, too many lines. So I wouldn't assume that you guys would run into too many problems, but if you do run into any complexities, that's where you might get into it, is that problem solving aspect. Feel free to email, put in EduCAD discussions. No one talks on the discussion page, but if one day you guys do, that'd be great if you wanted to. But if you don't, feel free to talk to me and I'd love to help. Here's a sample code. Your code must run with any set of input. Enter the number of assignments, -1. Number entered is incorrect. The number of assignments, 1 or more, -5. Actually, I take that back about looping through. This is better. When you loop through, you'll do this. But I was thinking a little bit more advanced than what I had originally put down. Enter the number of assignments, 1 or more, 3. Enter the score for each assignment, 1, -1. The score you entered is incorrect, right? We have a whole bunch of invalid statements. Then we'll have something that does work, right? So we'll say, do it again, right? In this case, we're saying do it again. The score you entered is incorrect. Try again. We didn't let that count. We didn't let that count. You can do however you want. I'm not going to critique the way you write the code. If you don't follow the steps exactly the way I wrote them, perfectly fine. It's just make sure that you get something similar working, where in the end you have 90s. If I give you this and I say enter score 90, 70, 80, student report is average assignment is 80, letter grade is B. So we're creating some student's grade. There's no weights to any of their grades, but if you wanted to be crazier and assign weights, go ahead. I figured that no one would want to do that because that'd be a little bit more work, but hopefully that's a good, this is a decent looping assignment. The next assignment would probably get more into list, but in this case, this loop is going to be a refresher of looping through assignments, where it's going to be, hey, loop through this. At the end, we already did this in the last videos. If anyone wanted to check as well, I think we did actually test grades, and then we calculated averages. So I almost practically gave you guys the answer to this code in this last week's video or 2 weeks ago video. So either week 5 or week 6 video, the answer is in there. Maybe Yeah, week 5 and week 6, maybe week 4. I can't completely remember. Probably in the loops and the video after the loops. That's probably where you'll find me going over this. So you guys can look back at that. And then I'll go back to my old thing, which was, why have I lost my thing? Is it this? Yes, okay, I found it. Perfect. So now we're back. If you have any questions, feel free to put in the chat. If you want to, I do not mind getting interrupted at all. So don't be afraid to do anything like that. And we will get into the test. This is the quiz. We could go over the quiz, but I feel like you guys would probably want to go over the test because the test is what I care about the most. Oh, I take that back. You can't do it through here. I have to do it through here, don't I? So module 4, no, not 4, but as you see here, week 4 to week 7 tentative. I think it was week 3 to week 7 really, and then the rest is going to be module 4. So next week we're going to start getting into functions, all that stuff. So this is the more complex stuff now. So we're finishing up module 3, and hopefully you guys look back at what you guys were doing from module 1, and you guys should probably see a pretty big gap of like, oh, you know, I've learned a decent amount. I can actually write a program now, which is something you probably couldn't have done unless you had prior experience in week 1. So now let's go and proceed with this code of honor. I will work, oops, we're not really following code of honor, but that's fine. I'm your guys' instructor, so it's okay. Here, how many stars will the following snippet send to the console? And I want you guys to work on this with me, right? So one thing we could also do, and I want to say this, is you could also pull up your idle and also do that. Like, let me actually, let me go and do this. I want to quit all my idles. I realize none of you guys can actually see what's going on my screen, I believe. I'll go show, I'll show that in a second once I close out. So I'm going to open up idle. Okay, perfect. So I'm going to do a new share, but it's just going to be on my desktop. So here we have the original desktop. So idle shell, if you want, this is a decent way. I would encourage, and this is the best way to learn, is let's work through this together and then we can find an answer at the end, right? So here, chat up. How many stars will the following snippet send to the console? I equals 0 while I is less than equal to 5. So we're going to start at 0 and go up to 5 and equal 5. We'll still count it if it equals 5. So it's going to go I plus equals 1 is going to be so we start from I is now going to equal 1 in this situation. 1% 2 equals 0. I always say percent. I know if you guys have been to my class, you guys know that I keep saying percent. 1 modulus 2 equals 0, which is going to mean 1 divided by 2. The remainder, what's the remainder of 1 divided by 2? We know that's going to be 1. Does that equal 0? No. So we print a star. Then we go there. And then, so we print 1 star. Then we're going to go through this loop again, and it's going to say I plus equals 1. 1, it was 1 last time. Now it's going to be 2. 2% 2 modulus 2, 2 divided by 2 is equal to 1 with no remainder. So this equals 0. This is true. Then we're going to break, and a break will kill our whole code. So technically, we would just say we printed 1. Now let's see if we got that correct. All I'm going to do is I equals 0. I still have caps lock on. Equals 0 while I is less than equal to 5. And this is a great, I like, you guys, I would say don't try doing this in the first place. Do this like after you figure out the answer, and this is a good way of testing your work. Or if you want, you can do it after you even do the whole exam. I would say that's the best case. Do it after the whole exam, and then if you want to go back and make sure you get 100% or pass the exam, go back and you can actually test what it should be. And then we said break, and then print star. And then here, oops, enter. And we printed just 1 star. So we were correct, right? So next. Here, I'll let you guys do this one. I'm not gonna do everything for you guys, but this one, I feel like these loop ones are good ones, good practice. This one is a little bit confusing. I looked at this one before. So in here, I want to see if anyone could figure this out, what this would do. So t is equal to bracket 3 minus I for I in range of 3, for j in range of 3. Now, let me just state this. If let's say I was your boss and you were a software developer, and if you wrote code like this and gave this to me, I'd probably be like, rewrite this, because this is really confusing code. So I would say don't try to write your code in this sense. This is probably not a good way to write your code, but this is something that Python does allow you to do. So it's good to know what Python does. Doesn't mean you should do it. Kind of like the break and continues that we talked about. Is like break and continues has their purpose, but sometimes you want to try and work without it because you want to think of a logical way without working with that, because break and continue can cause some problems. So t is equal to 3 minus I for I in range of 3, for j in range of 3. So what this means is we're going to create a list. That's what this bracket stuff is, where it's going to say 3 minus I for I in range of 3. So it's going to go in here and it's going to go, I is going to equal 0, right? Because whenever we do the for I in range of 3, it's going to go 0, 1, 2, right? And that's going to be 3 times, because 0, 1, 2 is 3. So it's going to say 3 minus 0, which is going to be still 3. 3 minus 1 is going to be 2. And 3 minus 2 is going to be equal to 1. So our list, we think, would be 3, 2, 1, because that's what we're doing here, for j in range of 3. And when we do that, that's pretty much saying, do this 3 times. So if I go into write this code out, t equals, what was it again? This was 3 minus I for I in range of 3. So if I do this, oops, t, right? We get 3, 2, 1, exactly what we just said, right? We went through the loop. It did 3 minus 0 is 3, 3 minus 2 is, or 3 minus 1 is 2, 3 minus 1 is 1. 3 minus 2 is 1, but we never say for I is 3. We don't say 3 minus 3 equals 0, because as you remember, range of 3 means 0, 1, 2. You don't actually hit 3. So here, what we'll do instead, and so what they do in the code is 3 minus I for I in range of 3. Am I missing anything? I don't believe so. For I in range of 3. And then they say in range, I believe it's in range, oh, for j in range of 3. So just like we said before, we said that it was going to do it 3, 2, 1, 3, 2, 1, 3, 2, 1. So we did it 3 times, exactly what we wanted, right? So now what we're going to say here is s equals 0 for I in range of 3, s plus equals t of I, print s. Now this one I want to ask you guys this question, see what you guys can think of it. So the question is asking, let me see if I can just write this in here. I'll write this in here. I won't push enter though. For in range 3, I believe that's correct. Sorry if I keep moving so fast. T sub I, and my brain can't remember all that. So this is what they're saying. And then actually it's okay if I do finish this code out, because oops, I did something wrong. S plus equals T of I of I. Oh, I did not say s equals 0 before I did that. Oops. Okay. 3 s plus equals t I. And so now we have working code. So once I print s, it'll tell me the answer. So what we have here is, if I wanted to do this what we have before, let's do it exactly the way I talked about in the last, when we were doing the checkerboard, where we said for I in range of len of t. I need one more. Print t sub I. Right, this is going to give it to us by row by row by row. It's kind of like that little check thingy, like the chessboard. So 3, 2, 1, 3, 2, 1, 3, 2, 1, right? So for I in range of 3, we have t of I, we're going to say give us plus s plus equal t of I sub I, right? There's nothing else. It's just going to be, in this case, I is going to equal 0, right? Let me get my chat up. So can anyone tell me what they think the first instance of t sub 0 is going to equal, right? Because we know I is 0, right? So what is t sub 0 sub 0? Sub 0 is, whenever I say sub, that's the shorthand way of saying bracket I. So when I say t sub I, that just means like at that position. So t at position I and I. Can anyone tell me what t sub 0 is? This is the same exact thing. All right, as t sub. Brandon says it's 3, right? Because 0, 0, just like we talked in the checkerboard, it's going to be this. So 3. What about the next one, which is going to be print t sub 1 sub 1? Anyone know what this is going to be? And as Brandon said earlier, it was row 1, column 1, right? So I'm going to call on, let me call on someone. Alessandra, can you tell me what this would be? What's 1 and 1? Oh, I'm going to sneeze. All right, maybe I'll sign that here. So t sub 1 sub 1 would equal 2, right? It's going to equal this position right here. And when I print t sub 2 sub 2, we're going to get 1. So if you think about it, what we just did was we got the diagonal of this entire checkerboard. And this is really important because there's going to be a lot of times when you code where someone's going to ask you how to find the diagonal. This is a good way to find out. You just do sub I sub I. So we just found the diagonal. So 3 plus 2 plus 1 is going to be 6. The value eventually assigned to x is equal to, well, this one I think you guys should get. Does anyone want to give me an answer for this one? This one's a funky one, but this is a good one. X equals 1, x equals x. And as a reminder, that equal sign means you're checking if those numbers equal each other, and x equals just one equal sign is assigning something to it. So can anyone tell me what this answer would be? True, exactly, Doctrine, because 1 equals 1, that's true. X now equals true. Exactly, good job. For this one, okay, this one was a good one as well. So this one, if anyone remembers, I had the code up. I don't know if I had the code up earlier, if I got rid of it. But in the last class, we talked about it a little bit, which is when we do this left two brackets, this like left, I think something bitwise operator, I believe it was called. All this is doing is 2 to the power of 1. If I made this number 2 right here, this would be 2 to the power of 2, which would be 4. If it was 3, it would be, it's whatever this number is times 2 to the power of this, right? That's the whole point. So 2 to the power of 1 is going to be 2. If I made this to the 10, it'd be 2 to the power of 10, which is, I believe, 1024. Am I correct for saying that? I think I'm correct for saying that. It's been a while since I remember those numbers. The power of 2s are very important in computer science. You'll figure that out at some point, just as it was binary, right? Binary is one of those reasons why. But var equals 1, while var is less than 10, we print a hashtag. So var is equal to var times 2 to the power of 1. So var times 2 to the power of 1, in this case is 1 times 2 to the power of 1 is 2, right? So 1 times 2 is equal to 2. Then we go back in the loop. We're going to print this for a second time. 2 times 2, because we said this is 2 to the power of 1, is going to be 4. And then we're going to go back in, we're going to print this, and we're going to get 4 times 2 again, 8. So if any of you guys notice the pattern here of that power of 2s I was just talking about, our first number was 1, then it was 2, then it was 4, and then it was 8, right? So power of 2s, 1, 2, 4, and 8. So now when we get to, let's say, if we were to get past that, if we will do, again, we'll go back in here, we'll do 8 times 2, 16, right? So 2 to the 5 is 16. All right, 2 to the 3 is 8. No, 2 to the 4 is 16, my bad. 2 to the 4 is 16. And so all we just said was, but we're not going to print that out because 2 to the 4 is 16. This doesn't equal that, right? So what we're going to have is we're going to say we printed it out when it was 1. Then we went back in, it was 2. Then went back in, it was 4. Then we went back in, it was 8. So we printed it a total of 4 times. 1, 2, 4, 8, right? Or 1, 2, 4, 8, if anyone watched my fingers. So that was 4 times. What value will be assigned to the x variable? Z equals 10, y equals 0. Now, in this one, I would like someone to tell me what the order is going to be. If anyone wants to run this through me. This one I actually got wrong the first time I did this. So if you guys want to do better than me, this is a good one to get right. So in this case, I guess I'll walk this through with you guys. Is this? I think we can do some of the parts together. I want to do the annotate. Okay. So if I have a draw, okay. Okay. So here, y is less than z. Is 0 less than 10? Yeah, that's pretty true right there. E. Is z greater than y? 10 greater than 0? That's correct. So that's going to be true. Or y is greater than z. Is 0 greater than 10? Nope, that's false. And z is less than y. Is 10. Is 10 less than y? No, that's false, right? Because 10 is not less than 0. Can someone tell me what the final answer is going to be now? Because I have these ands, these ors, ands. What's the way we do it? Is it going to be left to right like before? Is it going to be true, false? Is it going to be true, true, and then false? Is there a different way? Does anyone have any idea? This is a good test, which is pretty much, oh man, it's 4:59 already. Okay, I'll fix it up, but I think no one. So in this case, ands take higher precedences than ors. So what we're going to do first is we're going to do this first. It's kind of like this is your order of operations. 1, then we're going to do this second. I don't know why I wrote the number so large. And then we'll do this third. So true and true is going to equal true. And then we're going to get false. And then we're going to OR it, which, as you guys know, equals true. And then I'm going to clear all this, clear all my drawings, and we'll get true. If I clear it, let me exit out of this. Okay. True. Then we go next. My red dots are still there. These are good ones as well. I'll let you guys do these ones, but I wanted to go over some of them. Delete nums equals 1, 2, 3, vowels equals num. We'll go through there. These ones are good. And again, always remember to go through these and test them out yourself, or if you want, if you guys have any problems. So for this one, right, this is a good one as well, is 0, 1, 2, 3 for I in range of 2. Is when we print my list of 2 commas of 2, 0, we're going to have this list become our row is going to be 2 and our column is going to be 0. If it means our row is going to be 2, that means we're going to have 3 rows, right? Because position 2 means 0, 1, 2, 3 rows. The problem is when we do this, just like we showed in our earlier examples, this is going to print out. If I do this, actually, let's go and do that real fast, which is my L equals, and what they say, 0, 1, 2, 3 for I in range 2. What we think from what we did before, we'll know that we get this. And if I do the same thing I did in the past, which was for I in range of len my L, print my L, this is going to print out each row, right? My L sub I. So we're going to do that, print. So we get 0, 1, 2, 3, 0, 1, 2, 3, which means we have only 2 rows. So what happens is when I say print my L of 2, 0, we're going to get index out of range because there is no third row, right? 0, 1, there's no 2. If I want to do print my L of 0, 3, this will be perfectly legal because we have a fourth column, right? 0, 1, 2, 3, 1, 2, 3, 4. Our fourth column is legal, right? Because we start from 0, so 0, 1, 2, 3. But we don't have a second row or a position 2 row, which means we don't have a third row, which means that would trigger a runtime error. And then also from one thing that I'll let you guys test these things out. But there's also some things called negative slicing. Negative slices just work in reverse. So from -1, -2, like if I do nums equals 1, 2, 3, I'll go over this really fast. You guys should still figure this out when you guys do your things. You guys should be seeing this before me, but nums. If I say print nums, and we're going to say -1. So this is going to be everything up to -1. Oops, I just need to put one more parentheses. 1, 2. So what it does is it's going to go only print these things, and it's going to go up to here. So all it did was, it's like the same way we did before. -1 means print everything up to this element, right? Exactly when we talked about slices earlier. You can go to the negative. The negative just pretty much starts from the right side, going to the bottom. It's a good tool to have. Some people do use it from time to time. You can go by without ever using it, but it's just something you can add to your repertoire. So if I said -1, nums of -1 to nothing afterwards, right? Like how we talked about before, we're going to start from 3 because -1 is this third position. And we're just going to do 3, right? Because it's going to print that just like how we talked about before. And if I did -2, oops, let me just copy and paste this because if I do -2, we get 2, 3 because it goes down there. It goes down -1, -2, -3. It's weird how it works. It's funky. You don't need to completely ever use it that much, but it is good to have in your repertoire. And if you are taking the exam, it is good to have. So this is where something like that, right? Nums equals 1, 2, 3. If I wanted to do this, print nums, and if I did this where -1, -2, what we're going to have is we're going to go down to -1. We said was going to be this one, and it's going to go to this one. So what we're expecting to get would be 3 because we don't ever hit this one, right? So if I print this, we get nothing because we're actually going here, right? We're going backwards. So it would give you, oh, actually, you would get which of the followings are true. Vowels equals no. I'll let you figure that out, but you figure out that this one is now negative. It is an empty bracket because -1 to -2 is from here to here, but you can't, you're going a different direction, so it doesn't work. So it gives you nothing back. Funky. It's a funky thing it's a funky tool to have. I'll say that. But other than that, I will stop the share and I will end the